Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about a sheet metal component. I am going to create a 3D model and as well as 2D drawing. So this is the drawing I am going to create and I am going to explain step by step. So this is the model. So I am going to show you how to create these flanges, base flange and this vent feature and these cutouts. So here is the drawing. And I am going to show you how to create drawing for flat pattern with ordinate dimension. So now I have taken a new SolidWorks part file. Select the front plane, select sketch, take a center point rectangle, (381) 152. So go to sheet metal module, select base flange. Here I am going to take 2 mm thickness and K factor as 0.45. So the value should be always less than 0.5 depending on the material. Say OK. Now I am going to create edge flange. Select this edge, and this edge. If 4 flanges are created with a single base flange, then we have to select all the edges so that it maintains uniformity at this location, at this corner. Otherwise it's difficult to maintain uniformity. So based on the precision we can reduce the gap. Here I have taken 1 mm. We can reduce the gap, but manufacturing cost will increase. So the distance I am going to edit in the sketch mode. So here I have taken flange position as material inside. Say OK. So here you can see the uniformity. Now select this sketch and edit this. So 254. So similarly we have to edit other sketch. This is also 254. Now top flange. Here it is going to change the length of the flange. So here it is 51.
See, one more thing, we can have other option, like we can select these two lines. See, we can coincide like this, so that if we modify one of the flange, automatically it reflects on the other flange. So that is the advantage. Select unfold command, select this face, collect all bends and save. Now I am going to create these cutouts. So you can see in the flattened state. So I am going to create these holes initially. Select this face. So I am going to create a hole feature. Select this face and simply place this hole with 10 mm and come out of the sketch. So now we can go to edit sketch. So since it is a symmetric, I am going to draw lines to construction lines. So it is 153. So simply move to this direction, draw one more circle. Make it equal. Go to mirror command, select these two circles and select the center. So it is symmetric now. So the distance between these two holes is 178. So these two holes are constrained. Now select this hole center and this center, make it horizontal. See, this is also constrained now. Now draw one circle. Make it equal. See, the whole dia is 6.5. Select this, all the four circles and make it equal. So this is 25, center to center distance is 100. Now select mirror entities, select these three circles and select this center line, make it okay. Now this is 127. Now say OK. So these holes have been created now. See, we can hide these sketches. The show hide options. See here. Now once again I am going to create these hole features. So select this face, go to sketch, go to sheet metal, select this simple hole, select this face and come out of this sketch. Now select this edit sketch option. See, the hole diameter is 13. So we have to create 4 holes. Make it equal. Make it equal. So this is 51. So I have created the 4 circles. So it is center to center distance is 95, horizontal and vertical is 51, and diameter is 13, and distance from origin to the center point is 70. Say OK. Now I am going to create sheet metal cut extrude. Say 80. This is 10. $70. This is 38. So select this rectangle and select fillet command. So it is 5 mm. Say OK. So now I am going to create 2 more cutouts. So this is 19. This is 5. Make it equal. The distance between 2 lines is 51. The origin to this distance is 90. select this line and this line, make it collinear. This line collinear. This is 12. See, the sketch is fully constrained now. Now say okay. See here. Now I am going to create this vent feature. Select this face and create a sketch. So draw a circle. So this is 100. Come out of this. So select these center points and make it horizontal. Now draw one rectangle. So the distance between horizon and this line is 39. Now draw one more circle. Select these 4 lines and make it equal. It has to intersect. Now we can trim these lines with power trim. This arc. Now select this line, this line, this line and this line. Make it equal. And make all the 4 arcs equal. So this is 47.5. So here we can hide sketch relations. See here. This is 30. $48. 72. Now select this line. So we have created this line joining all the midpoints of these lines and arcs. Now we have to go to sheet metal module and select vent feature. See here, in boundary condition we have to select all the arcs and lines to create the boundary. See, it is created now. Here I am going to take 2 mm equivalent to sheet thickness, and I am going to select these ribs. See, this is for filling the boundary. Now we can add some radius. I am taking the same 2 mm to improve the strength. Say OK. So the vent has been created now. I am going to hide these sketches. Now we can see this vent feature. Now I am going to create the hole feature. So select simple hole. Select this face. Say OK. Edit this sketch. This is horizontal. This is 100. 20 diameter. Now select this and make it construction. Say OK. Take center line. So this is 45. So vertical and horizontal lines are for mirroring the circle. Now coincide with this point. This is 2 mm. Select mirror. Say OK. Once again mirror entities. Select this. Say OK. Similarly, I am going to draw whole features. Select this face. This is 6 mm. Go to edit mode. Draw a circle. Make it horizontal. So the distance between center line and origin is 100. This is 120. Make it construction. Mirror entities. Select this circle and mirror about the center line. So once again select mirror entities, select these two, now we have to go to sheet metal module, select fold option. So it automatically takes this face, collect all bends and say OK. See here, component has been created. Next I am going to create this drawing in folder state as well as in Flat Pttern. So I am going to show you how to create this drawing in folder state as well as in Flat Pttern. I am going to show how to place ordinate dimensions. I am going to share this drawing in PDF format. You can check in the description. So I have taken a new SolidWorks part file. So here I am going to place the model. So this is isometric view. So we have to go to model views and place the model. This is the Flat Pttern. So this is the front view. Now here we can place projected view. This is top view. Right side view. See, before that we have to set the sheet dimension. So we have to go to sheet properties. So here I am keeping scale 1:4. That will reflect in the all the views. Now I am going to select this view, and here we need to select use sheet scale. Notes should be all dimensions are in mm. So material we have to specify whether it is mild steel or cold rolled steel, and sheet thickness it is 2 mm, and bend radius is equivalent to sheet thickness. Now I am going to place the dimensions. So we have to be careful. We have to place outer edge to outer edge. So length, height. So initially we have to show the overall dimensions. So this is a flange length to flange length. So we can delete here so that we can visualize the flange length exactly. So we have to place this detail view. So for that we have to place one more view in the drawing. Keep it in front view. Here, instead of sheet scale, we have to custom. So I am keeping 1:2. Now I am going to crop this. So select crop, and here we have to take a spline. So this is crop. Rearrange the views. Now we will go in detail with features. So annotations, select smart dimensions. So either we have to give from this distance to the edge of the flange or center point. So I am selecting center point, right click, select midpoint and select this edge. So mostly we provide to the midpoint. This is 19. See, we have to verify the font. So documents, units, mentions fonts. So here it is 10 points, that is fine. So we have to verify while placing the font size. So here we have 4 holes, so we have to write 4 into x. So we can provide one of the edge to the hole distance. This is important. This is for positioning. Now we have to rearrange the dimensions. This is very much important. See, we have to move little bit inside. You can flip this. If it is in other direction, then we have to move inside. So we can place this in other direction. See here. See, for vent dimensions, instead of placing here, because the view become clumsy, so we have to provide other dimensions in the detail view. So here we need pitch circle. See here, we have to show this pitch circle. So we have to place with a sketch. So here we need to select perimeter circle. So we have to go to exactly the center of this circle, and here and here. So 3 points. So it automatically takes the pitch circle. Select this circle and make it construction. Now we have to place these dimensions. So we have to flip this arrow. See here, it is a 4 into x. This dimension also is 4 into x. See, we can show this dimension, but we have to keep it as a reference, because we are already showing this pitch circle diameter. So once we place these dimensions, then only we have to show these center marks. Otherwise, sometimes when we modify the model, it goes to the dangling. So we have to provide here also. So this detail is done. Here also we have to provide the center marks. See, whole positioning is very much important. So here we have to show this distance also. See here, we have to place this dimension and this dimension. See, in drawing, every model is different from other model, so we have to keep placing the dimension and we have to rearrange it. This is the general practice. Straight away we cannot place dimensions. So as soon as we are adding the dimensions in the view, we have to rearrange every time. So this is usually for creating a new model. If we are converting from drawing, from this drawing to model, then it's not required. We can see the drawing and we can place the dimension. See here. Here also we have to rearrange. So we have to move this view a little bit down. So here we have holes in both the sides. So select these two dimensions and we have to type 2 into x. See here. So it should not overlap on the arrows, so we have to flip this and move this dimension. So this is how we have to do it. Positioning of holes. So here we have 3 holes, so 3 into x. Similarly the other side also. We have to place other side, it is mandatory. 2 into x. Because manufacturer cannot go with the assumption. So this here we are placing 2 into x, it is considered for these holes, but this for positioning we have to place both the sides, otherwise there is a possibility of a defect in the part. (18 into x). So this we can keep it as a reference because already we have placed it in the other side. This is from flange to hole diameter, hole center. So we can keep it as a reference. So here also 3 into x. And we have to place the center mark. This is the best practice. After placing the dimensions, we have to place the center marks. So here also we can have holes in other directions, so this side and bottom side. So here also we have to place 2 into x. So dimensions in folder state are completed. Now I am going to show how to dimensions in flattened state. So insert the model. So it is taking the flat pattern. Keep it in front view. So we have to verify the scale. So it is a sheet scale. So that is 1:4. Place it here. And insert one more model for isometry. So right click on this model, go to properties, select default. So it selects the default configuration. Now I am going to place this ordinate dimension. Go to annotation, select vertical ordinate. So we have to place one by one. So here we have to place in the midpoint. This is end to end. Edges are very much important. Now select vertical ordinate. Each and every feature and edges. See, in form state we have to show from midpoint, but in ordinate dimensions we have to show from edge to edge. So we have to select similarly the other side also. Add ordinate, and we have to place from edge to edge each and every feature. That's very much important. This edge also. See, we have to show the location of this center. So for that what we have to do is select once again this perimeter circle and join these 3 center points. Select this and make it construction. Now we have to add ordinate dimension to the center point. So select this. See here. See, sometimes the dimensions are increasing. So what we have to do is we can place some of the dimensions in the other side. For that, what we have to do is add vertical ordinate, and once again we have to start from here. So wherever we have added the dimensions, we have to delete those things. See, here to remove this, we have to select, uncheck this jog. It becomes right click, display, uncheck this. Here also remove this jog. Now we can rearrange the dimension. See, here we can add jog, move a little bit inside. So we have to show 0 and 0 in one direction, and this one we have to hide it. So we have to right click and select hide. So here also we can see more number of dimensions. So we have to add ordinate in other direction. So add from here. So we will add these dimensions in other. Otherwise it's very difficult to read. So wherever we have added these dimensions, we have to delete in the other side. Now we can move dimensions a little bit outward. So add a ordinate dimension, and we have to place this. So we are placing 0 dimension in one side, so we have to hide the other side. Here also we have to add this ordinate dimension for the center of the vent feature. These dimensions should be near to the edge of this view, so that it's easy to read this drawing. See, here also we have to place near to this view. We have to show this whole dimension. So we have to type 4 into X. See here it is not 4 into x, it is 18 into x. Now after placing all the dimensions, we have to go for center mark. So we can click here for all the holes. And now we have to see each and every dimension. So this dimension is for 2 holes. So we have to type 2 into x. Similarly for this dimension 2 into x. See here we have to show this for this dimension also. So add ordinate. See, while creating this new drawing, so we have to verify each and every dimensions whether we have covered all the dimensions or not. Now we can see this dimension, and this and this is for 2 features. So we have to type 2 into it. So we can type at a time. Similarly for other sides also. For these 3 dimensions, it is 2 into x. So these dimensions is for 6 into x. So this is for 3. See these whole dimensions we have to add. See here. So you have to add jog. This is 3 into x. So here also this value is 6 into x. Similarly, if you want to place details of this vent feature, we can place similar to this folded state. So here I am not showing. So I am going to share this drawing, so you can check the description of this video. So this is about creating a sheet metal component in SolidWorks. Thanks for watching.